My name is Dr. Bradley Alisea, and I am the principal investigator and head scientist at the Orthogonal Research and Education Laboratory. We're located in Champaign-Urbana in Illinois, that's south of Chicago, but we operate worldwide, as you'll see in the talk. And this talk is going to go over some of the activities that we do in this group, in this lab. And so we're present all over social media. We're present in the form of a website on Weebly. We're present as a GitHub organization. We're also present on YouTube quite a bit. So we're going to talk about a playlist that we have and a YouTube channel with a bunch of content on it. We also have a LinkedIn page, a Medium blog, and a Twitter feed. And so you'll want to follow all of those things to get the full lab experience. So today I'm going to talk about the distributed enabling computational laboratory. And that's something that's what we call ourselves. We're a very unique outfit. We do a lot of academic work, but we're not located in a university. And so we're doing a lot of interdisciplinary work. And this meta-archive preprint describes our approach and our institution, especially with respect to some of similar institutions such as the Ronan Institute and other organizations around the world. And so this is the abstract. I would definitely recommend going to this link, downloading this paper, and reading through it if you're interested in our laboratory. So what does Orthogonal Lab mean? I've had that question posed to me a couple times, actually. So the term orthogonal, it's an adjective, and of course, if you're a math person, you know exactly what I'm talking about. If you're not a math person, you may not. So there are two definitions here. One is of or involving right angles, or at right angles, and below you see this geometric set of planes that are located at right angles to each other. So these three planes are all orthogonal to the others. And this shows you in a coordinate space what that looks like. But there's another definition that is of variance, statistically independent. So that means that statistically, if variables are orthogonal, that means they're independent of one another. And it's actually, that's related to the geometric definition as well. The reason why we use this term is because we're engaged in research that at first glance don't seem to fit together very well. We do all sorts of things. We have initiatives in developmental biology, in AI, in cognitive science, in data science, in theory building. And so all those things, when you look at our menu of things that we do, they don't look like they fit together. However, if you take a look at a map of interdisciplinary space, such as the one here, this network, I guess it's a citation network of different fields and how they fit together, you see how these things come together. So the reason I picked the name orthogonal was because the things seem to be at right angles, but they're connected in many different ways. And so that's the sort of spirit of the lab. We like to make connections between things, even if they're very disparate. So another thing that defines our lab is that we engage in a lot of interdisciplinary research initiatives across different areas. And this is something that we really kind of take to the limit here because we have a very lean organization. We don't have a lot of institutional inertia, and we don't have a lot of people with legacy interests. And so what does that mean? So we have different dimensions of research interests. So, for example, most labs don't conduct research in developmental biology, computation, and behavior. Most departments don't do that. It's very odd. It's a very unusual combination. And if you were to go to a university, you would have to travel all across campus to try to put those things together. But in our lab, we put them together quite effectively. What are our guiding principles? Well, one of these is actively unsiloing different areas of research. So it's not enough to just say you're being an interdisciplinary person. It means you have to actively unsilo these areas of research. And so when you're engaged in the research, oftentimes the implication is that there's a silo there. And we're trying to unsilo all of that. That fosters in turn some sort of lateral thinking between research domains. So if you're doing research in behavioral biology and philosophy and developmental biology. You can bring those things together in a pretty seamless way in our group without too much uh, institutional inertia. And so that brings us to our third point, is that we have a lot of opportunities for people to make very small contributions and still be a part of the group and still contribute to the group. So one of the things we stress is that education is important as a research practice. So to do research, you have to be able to learn the fundamentals of research, but you also have to engage in education. And this is active education, where you're learning and you're reading and you're presenting and you're doing a lot of things that help you to understand the basis of what you're doing research on, and it's all sort of connected. So if you want to read more, there's a link to our Open Science System website, and I encourage you to go read that. So we talk about coordination, but how do we achieve coordination in our group? And so as an academic institution, we publish, we value publishing, we value collaboration, and we value some other things that are sort of the secret sauce or the missing ingredients here. So we have a GitHub repository, we have a GitHub organization, and this allows us to measure contributions and collaborate in a version-controlled manner. We can make pull requests, we can edit documents, we can put them into the public eye, and we can put archives on GitHub. And it's all very nice and quantitative, and it allows us to interact publicly. So it's all transparent as well. We do a lot of document sharing. We do a lot of sharing code and sharing of data and manipulating these things in the cloud. And so this is augmented with different tools such as Google Drive and Open Science Framework. So for example, we'll write a paper in Google Drive or do a presentation in Google Drive. We'll store things that we might present at conferences in Open Science Framework, and it's available for people to download if they're interested in a topic. It's mostly transparent, so they can access everything that they need to see success and to get going in a project. We have this MMI, which is something that we've been developing over the last couple years. This is our sort of approach, because we're virtual, and I'll get to that in a minute, but we're an entirely virtual organization. We have to have a method for sort of bringing together our collaborators into a community and making it an effective work unit. So we do messaging, we do meetings, and we do ideation. And so if you think about that in terms of applications, it's Slack, Jitsi, which is a teleconferencing platform, and then taking ownership, which is not a technology at all. In fact, it's just a behavior that we like to foster with people. We like to help them take ownership of projects, whether it's starting their own project or taking a little piece out of a project. This is something that we really value in our organization, and it helps people to get a foothold in an area and perhaps learn more about it and perhaps become an expert in it. We also engage in open publishing. So open publishing is key to what we're doing. We do a lot of versioning, so we put out different versions of a document. We do a lot of promotion of the open publishing artifacts, and then we allow for open access to our publications, because if people can't read them, they're not really worth anything. So in this sense, we use a lot of, again, we leverage a lot of technologies. We leverage a lot of approaches that are technologically based. So for example, we use Figshare, we use blog posts, we use preprint servers, we use Twitter, and we use Slack. And so all those things are enabling technologies for us. So I wanted to go over this for people who don't really know how we, they can kind of imagine how we push things out through a research pipeline. But this is it. This is laid out in front of you. We might start recruiting people, and then we get them into the organization, and they say, how do we produce research? So the way we approach it is we have discussions and papers that we read. So we have something like a Twitter feed and a ResearchGate feed, and we pick out papers and we discuss them. We discuss them at research meetings, which we hold both synchronously and asynchronously. So when we do a synchronous meeting, we're on video. We come to the meeting, we spend about 2 hours in the meeting, we go over business, we talk about maybe some research, and then we review some papers and talk about them. If we're on Slack, we record the meeting and then put the recording, make it available on Slack, and then people can look at it, say after the meeting is done. If they're maybe 8 time zones away from us and they can't make the meeting, they can view the meeting later and then take information out of that meeting and write some notes out and then share it in Slack and communicate with people. That's an asynchronous approach, but that's another component of our collaboration medium. And so then we also take things and we put them on our blog, which is we're our Medium blog. And this is for purposes of fostering discussion. So this is an asynchronous thing where we take maybe clips from the video and mention them in a Medium post. Or we might have people write longer, sort of proposals for research or ideas that they're exploring, and they have them out in the public eye so people can comment on them and discuss them in the meetings, or, push them forward even to become some sort of publication, which then goes to the research website or a ResearchGate, or it becomes a preprint or a talk. And even a preprint or talk can become a publication. And once we've done all this, we always like to preprint everything. If it's a paper, if it's a talk, we like to archive it. So we use a number of technologies such as GitHub, Google Docs, and Figshare, and all of those things can archive different things. Like, Figshare can archive data, GitHub can archive code, GDocs can archive docs or allow you to work with docs across multiple collaborators. GitHub can do this too to some extent, but we try to optimize that mix. So I had a model, I sort of developed this model in 2015, and I've been modifying it ever since. This is the most recent model, and this will no doubt change in 2 or 3 years. This allows us to go from open discussions to research artifacts, and it fosters a culture of openness, transparency, and flexibility. So in the last year, this laboratory has changed a lot. We started in about 2015, 2016, and it really got going maybe in 2019. And so up until that point, it was a very low throughput affair. We had a couple collaborators at a time, and we were doing things very sort of informally. This was before the COVID pandemic. And so we were already starting to maybe gain a little bit of scaling up before the pandemic hit, maybe like months before the pandemic hit. But then once the pandemic hit, there were a bunch of opportunities that arose that allowed us to scale up quite a bit more and develop the lab a lot faster than would have normally been the case. So before the pandemic, it was very informal. After, it became a much larger affair, but the philosophies stayed the same. So throughout our history, students and collaborators can become affiliated with us. They can take Orthogonal Research and Education Lab on as an affiliation and work on projects or topics of their own choosing. It could be people who are independent researchers. It could be students who want to, build up some expertise in an area. It could be lifelong learners. It could be retired professors even. And they can take on the affiliation and work with our collaborators and use our infrastructure to do great things. And so the pandemic really accelerated our growth and development. This table tells us what happened before and after the pandemic. So how did things change? Well, this model worked well before the pandemic, but after the pandemic, or after it hit, the model works really well. It turns out that we did most things virtually before the pandemic, and we did some things in person. But after the pandemic, everything became virtual. And that was really a strength of what we were doing, because about that same time, you started to see technologies become mature that allowed us to really move, and institutions for that matter, allied institutions that allowed us to move forward a lot faster. So we were mostly virtual before the pandemic. after the pandemic, we were all virtual and we were able to scale up effectively. We may introduce some physical activities after the pandemic is abated, but I think the virtual side is really one of our strengths. Before the pandemic, we focused on a few collaborations, which were independent projects. After the pandemic hit, we started to focus on topical projects with some crossover potential. So you start up a project, and the project would be judged on its merits, but also the sort of the potential for crossing over to other projects. And in fact, that's encouraged. We also have allied institutions. So before the pandemic, we were involved with the Open Room Foundation and INCF, which is the International Neuroinformatics Coordinating Foundation. After the pandemic hit, we were not only affiliated with OpenWorm and INCF, but we were also affiliated with Neuromatch Academy and most recently the Rockwire Initiative at the University of Illinois. And so the Neuromatch affiliation, Neuromatch is a summer school, the Neuromatch Academy, and they allow students to go for a couple weeks in the summer and get trained intensively in the computational neurosciences. So they learn a lot of quantitative methods, they learn a lot of things about neuroscience, and they need to do projects, which we support. We also support pre-academy training to get people ramped up in different skills. So we're upskilling people, and then we're helping them achieve an educational goal. But we're also engaging in some research projects, because they have projects during the academy as well. So we leverage our connections with OpenWorm and INCF in that case. The Rockwire Initiative is a informatics initiative. So we're kind of in the planning stages of now what that's going to look like. So stay tuned. That's going to be an interesting collaboration. So we're always looking for partnering institutions. A lot of these institutions are virtual, or they are virtual friendly. So there's a good opportunity for this sort of virtual to virtual crossover. So I wanted to talk about some of the people who have been involved in this, put some faces on this philosophy. And so I'm featuring 5 people. There are many more people who, kind of come maybe sometimes, for a little while. Maybe they come every once in a while and they do some collaborating, or they're pretty heavy contributors or pretty heavy collaborators. And so let me give you an example. So the first person is Stefan Dvoretsky, and he's from Munich, Germany, and he's at the Technical Institute of Munich. And he was involved in Google Summer of Code in the year 2019, and he developed this platform called BroadGenBrain, which is an open source embodied AI platform. He developed the platform, and then he went and was going about his studies. And recently he's been interested in coming back and opening up the platform for open source contributions to grow the open source aspect of BroadGenBrain. So, he's an example of someone who was able to achieve an educational goal, but also is now wanting to achieve a technical research goal. Jesse Parent, who is someone from New York. He's from Albany, New York. He went to the University of Albany, and he's interested in a number of things. He started out in the lab as a Google Summer of Code applicant, but then he migrated into sort of found his strengths in lab management, and now he's actually leading up 2 projects, one in cognition futures and one in AI ethics. And so he's someone who kind of found his way within our organization. It's quite impressive. But this shows you how this works. You have mentorship, you have research opportunities, educational opportunities. You're not located in the same place, but nevertheless, you're able to migrate and find your path and find success. Rishikesh Kulkarni is from Pune, India. And again, I have 2 Indian students here showing that, we can do this international, and Stefan is from Europe, so we can do this international collaboration. And in Rishikesh's case, he's very brilliant. He's done a lot of different types of things. he's interested in computational culture. So we met independently and fashioned some projects that we were doing, and we've gotten a couple papers out together as a result of that. So it's a very good opportunity, I think, to find new collaborations and to push some work forward that you might not otherwise be able to push forward. Rob Stone is from Michigan. He's from Detroit, and he has a number of different interests in cybernetics and philosophy of science. Notice it's quite a bit different from what you see with Stefan and Hrishikesh. It's closer to what Jesse's doing, but still, you can find you can engage in these types of research just by, showing up, putting in the initiative, and then finding your path. And then, of course, it's enabled by virtual technology. So we're collaborating virtually. Again, he's not located in the same place as the lab is physically. It's not really physically located. I mean, it's, there's a home base, but it's virtual. So, and then finally, Shruti Rajvansh Singh, who is from Jammu and Kashmir, India. And she's interested in a number of topics: deep learning, cellular automata, AI ethics. And Jesse and her collaborating on the AI ethics thing. So this is a case where I am the head scientist, Jesse is a lab manager, and then Jesse is actually getting people involved in a project that he's leading up. So you have this sort of chain of people. Sometimes you get people who start a project, I give him the agency to start a project, and then he's giving her the agency to work on that project and find a spot. And then, hopefully she finds her own path and then either, stays with that project or moves to another project. And that's how science really works. But we've sort of made this a lot easier to do without a lot of institutional inertia and overhead. So one of the big things, of course, is synergy between interest groups. We have a couple of different sort of main interest groups, and then we try to find synergies between them. So one of our groups is DevoWorm, and we have, I say DWML. We have a sort of a DevoWorm. It's developmental biology. There's a computational side to that. There's theory. There's data analysis. We have a specific focus on machine learning and how, you can use that to, do analysis in developmental biology. It's not something that it's pretty cutting edge. And it's definitely something that a lot of people are interested in. But you get interested in the machine learning side, and then you can learn something about developmental biology. So one of the topics that we cover there is data-driven feature selection. So we look at data sets, biological data sets. We use machine learning tools to extract quantitative data. Then we look for, features. We do feature selection on developmental data. And then we, maybe come up with some, cutting edge type of analysis to apply to it, or maybe just, write up a paper. You might be the first person to analyze the microscopy images of some really, lesser known model organism. And so if you just apply a method to something like that, we can access a lot of open data sets and drive research like that forward. It's a pretty exciting group. We have group meetings once a week, so we kind of lay out our agenda and then we kind of engage in things as we go along. We also have Saturday morning NeuroSim. This is different from the DevoWorm and DevoWorm ML group in that we're more interested in sort of the brain and cognitive science and neuroscience and computational neuroscience. So we're in this group called Representational Brains and Phenotypes. That's our sort of research group, and this is sort of the meeting name. So our meetings are Saturday morning NeuroSim. We meet Saturday mornings. We focus on neural simulation and artificial intelligence. It's a little bit broader than that, but one of the things we focused on is representation-driven behavioral simulation. So Stefan's work, Jesse's worked in this area quite a bit, and we're trying to develop new techniques. We're also trying to do cutting edge science in this area, and we're trying to do it all sort of in this synchronous asynchronous model. So there are a number of topics which span interest groups. So a lot of times, often we'll get things that start out in Saturday morning NeuroSim and migrate over to DevaWorm, where we start off with something in DevaWorm, some topic in development. It migrates over to Saturday morning NeuroSim. We get crossover attendees and we get crossover ideas. So we encourage these combination of themes across interest groups, and we do these additional discipline-specific deep dives and sources of expertise. So we try to encourage people maybe who have an expertise in one area to like learn about another area and collaborate with people in different areas. So we can like we can really produce some really innovative cross-cutting work. So one of our examples, of course, is DevaWorm. This is computational developmental biology. Another one of our examples is representational brains and phenotypes. That's the group that sponsors Saturday morning NeuroSim. We do computational neuroscience, cultural modeling, AI, and synthetic behavior. Well, we also have other initiatives, and these cross-cut these groups, these interest groups, one of them being participatory education. So at participatory education, we offer video lectures, micro-credentials, open syllabi, project mentorship, and digital learning, all just kind of like for different topics. And so we're involved in things like the OpenWorm Academy, which is the educational mission of OpenWorm. We are involved in Google Summer of Code, where Google sponsors a student. They pay them to join your organization for a summer and do some sort of code-heavy project. And then we try to make it so that they're actually integrated into this model. So they end up really, I think, benefiting a lot more than they otherwise would. And a lot of people continue on with us in some capacity. So we also use YouTube and Badge List as technological tools to drive forward a lot of this. We also have an open science initiative, and that cross-cuts our interest groups as well. So we talked about earlier how open data and replicability and sort of this meta research focus, this focus on research integrity and research openness is important. And so we actually focus on not only fostering open science practices, but studying them as well. And so we've been involved with a number of initiatives, the eLife Community Ambassadors, and the Mozilla Open Leaders program, and other groups that have been allied with us in this interest. So we approach this using something called an open mentorship model. And this is something that I drive forward mostly, but I'm starting to get other people involved in this as well. So mentorship can be sort of fractal. You can be like a head of a lab and you can be a mentor. You can be like an advanced student and mentor someone who's less experienced. So it's always good to start at the top with some strong principles. And so small contributions can move along larger contributions or projects. Participants make as many contributions as they would like, as they're comfortable with, or as that they have time for. And then the mentor, gives them feedback and evaluates them accordingly. But they don't judge them on like how much they can accomplish in a year. That's not the goal here. The goal is to do things like short talks or toy projects or skill building tasks, something that gets them in the door. And then they integrate these activities once they start to do them into a larger project. So they don't start a project just by tackling the world, to start off with. They just start very small and they do these manageable little things that will then add up into the sum of the parts is going to be, what you're going to have is what's greater than the sum of the parts. You're going to be able to complete a successful project. It's important, to assign where interaction is difficult. So, to be able to see where people start to participate and then drop off, and then, maybe they fail and then get discouraged and leave. So, the idea is that you want to circumvent this sort of participation gap You start participating, you're really excited, then something happens, maybe you don't experience success once, and you decide, well, this is not for me. Well, we're trying to avoid that sort of pattern. We try to keep people engaged, and it's not always successful, but we at least try to address it. In the case of our developing a project, the mentor assigns the broad outlines of the task, and the mentee defines the details of the task. It requires the mentees to take ownership of things and to be proactive, but the mentor also has to sort of encourage that behavior. So, laboratory contribution philosophy is where you join the group, you define your contribution, and then you make an early contribution, and that can be something very small, just showing up to a meeting, or making a comment, or giving a short presentation on a paper, or something that gets you started. Then you do the work, and you do additional work on it, and you either fail or you succeed. Sometimes you do both in different ways. That's where the mentorship and learning comes in. The mentor will encourage the person to focus on what worked and not, ridicule them or, make them do it over necessarily, but just to kind of get them into this pipeline. And then eventually the person has a redefined contribution, and then they can turn this into something like authorship, where you're authoring a piece of code or a paper or some media, or you're creating documentation, which could be like a wiki stub or a presentation, and then you release your external collaboration into the world, and that's where you find success. So you can redefine your contributions as a member of the lab. One of these contributions in the X column can turn into multiple Ys, and what I mean by that is, let's say I start out with some sort of outreach thing. So say I do a museum exhibit and I want to drive that forward. So I start out with this little exhibit, and then, I'm talking about maybe a virtual museum or a physical museum. And then you drive it forward, and your goal is to drive it forward, but you end up making multiple contributions. So you start working on your museum exhibit, and you complete the task, and then the next step would be maybe to continue doing this. Maybe you do it the following year, but you can also then create a blog post on the experience. And so then that drives forward this virtuous feedback where you're able to maybe build upon that success. So you find, say, your museum exhibit was a success, you want to communicate it to people. Then maybe you want to do an online talk about it. Then maybe you want to teach other people how to do something like this. So you would create a micro-credential or a video or something. So this is just one of many things that you can do. You can, say, do an online talk, and you become successful at it. So you do another online talk, and you do a blog post on the original talk. So you can build this body of work. Then we put a lot of this practice into things like static dashboards. This is an example from DevoWorm where we have, and this is based on sort of this idea, there's something called the credit taxonomy, which is a way to give authors attribution for their work in scientific papers. And so instead of fighting over the order of authorship, they give people these badges that say, I did this for the paper, I did that for the paper, and so forth. This is a similar principle where if you do something, you get a colored badge, and then your name is listed with all of your badges next to you. So it gives people an idea of how active you are in the community, how diverse you are in the community. And then, that's something that people can point to and say, this is how I contribute to the community. So every topic, every category here has a different color. And so some people have a lot of badges and some people have only a few, but that's probably okay. I mean, some people are specialists. Some people want to do everything. It doesn't really matter. It's a matter of just giving people credit for what they're doing. And it's interesting that, when people see this, they kind of invest maybe some time into earning a position in the lab. So in the lab, one of the things I do is I give people titles based on maybe their strengths. So Jesse became a lab manager because he applied himself in that area, and he became very well, he became practiced in it, and that's what he wanted to do. So he became a lab manager. I have another person who's become an editor because they like to read through papers and suggest changes and, do things like that. And that's the way they want to contribute. So that's their title. And so you can earn, as long as you apply yourself, you can earn your own niche. And then, of course, you can go to other places with that skill set, and it opens doors for you, perhaps. This is the structure of an open source scientific organization. I show this graph because this is an analysis that was done on the Open Worm Foundation, and I've replicated this with other groups, and I found this to be true. So what this is it's an analysis of Slack messages by the number of contributors in the community. And so this is just a very rough measure of community involvement. But I wanted to point out something here. So we have all these categories in the Open Worm Foundation. And this is a foundation we're affiliated with, but they have a much more sort of defined structure than we do. So this is actually a good example. So if you notice, there's a pattern here of data. And the data is that you have a lot of individuals who make maybe relatively few contributions. You have, by contrast, a smaller number of people who make a larger number of contributions. And as you can see by the legend, those people tend to have, defined roles in the community. So you see that there's this group of heavy contributors with a long tail of people who are maybe contribute less. And that's normal in an open source organization. The people who contribute less might just be like people passing by, people with a passing interest in it. It could be people who aren't encouraged to take on a role, or so we don't really know whether this is just to be expected or if this can be changed through some intervention. But you do end up with this area of heavy contributors. And those heavy contributors are people who maybe head up a project or involved in the administration of the project. And so that group of people are the people who are sort of these people who sort of take ownership of the projects. And I don't know if it's necessarily that they're successful and everyone else isn't. It's just that those are the people who have taken on those roles. And so, but remember, we do have all these other people out here who maybe contribute less often, but still are in the organization, and maybe one day they will contribute more. Or they might take what they learn, as a very casual contributor and take it back to some other home institution, and it might enrich someone's life. So we never want to exclude these people on the long tail. But we do want to point out the structure, and it helps us understand kind of what, how we need to focus our efforts. So we have this synchronous and asynchronous coordination. We use a combination of technologies. This is what it looks like. We have, when we were doing things physically, this is what a physical meetup would look like. We do the virtual meetups, of course. We do things like edit papers during meetings. So we'll do this in something like Google Docs. And then we have our Slack review weekly. And, this helps us bring the asynchronous people into the synchronous meetings. So we kind of developed this idea of a theory hackathon, where we were developing theory in this sort of hackathon environment where we'd meet for like 2 or 3 hours and hash things out. We also have Saturday Morning NeuroSim. The reason I point to this specifically is because this just shows you kind of how this is set up. You have the Slack reviews, you have the meeting that goes on for 2 hours. We meet Saturdays from 2 to 4 p.m. UTC during North American Daylight Savings Time. So I think it's like 3 o'clock to 5 o'clock the rest of the year. We're live on Jitsi, so we use our Jitsi teleconferencing. That's us here in a meeting. And then we also do, we upload it to YouTube, and we have this playlist of meetings from weeks past, so you can actually go back to the archive. I mean, often we do, and pull out conversations and put them on Twitter, and then maybe build a conversation around it, or put it in the Slack for the asynchronous people, and it works out quite well. Finally, we coordinate our efforts sort of not only by what's going on in the present, but we go into the past and we look at different fields. When we do our interdisciplinary investigations, we want to coordinate our ideas in terms of like what's been done and what the field looks like. And so we can then get a sense of how fields overlap. And so we invest a lot of time in building these knowledge maps. And so on the right, you see a graphical history of machine learning. This is a very coarse-grained one where we just kind of like look at like different things that contribute to modern machine learning and when they sort of happened. And then we can like take another map of, say, like some other field and match it up and see where maybe they have intersected in the past, or areas where there might be like, synergies that maybe are unexplored or may be explored in the future. This is a history of open access. So this is another map where, we kind of put these events, watershed events on the timeline going from, I think, 1942 to last year. And, we can do the same thing. We can match it up with another such map of, say, like, philosophy of science. And then look at like how you can make like synergies, or things that have been underexplored, underutilized, or things that maybe happened and failed, and then why did they fail? So we can do a lot of this, and this sort of is the basis for this Cognition Futures project of Jesse's. But it's a good way to coordinate your efforts and to look at like the history of different fields and kind of figure out new fertile areas to investigate. So I encourage you to get involved. We make these calls for participation. We have them on our Medium. And, we have different projects that we're kind of recruiting for. So the projects just don't come out of nowhere. We kind of come up with an idea of maybe a potential project that we're interested in, but we don't have the staff or the ability to drive it forward on our own. So we're looking for people to be involved in these things. If your expertise is already trending in this direction, I encourage you to maybe get involved. If you don't know anything about any of these, but they look fascinating to you, I still encourage you to get involved, because we can always find a place for you in the project. And you'll learn something along the way, and you may become an expert in it eventually. And so we have a number of tools. I guess the take-home message of this talk is we're using tools for the future of research, as well as tools for the interdisciplinary research future. So no one knows in the future where things are going to go, especially in an interdisciplinary context. There are a lot of potential pathways forward. There are a lot of tools that are enabling really exciting different types of research and cross, discipline research. And so it's an exciting time, and we're well positioned to take advantage of that. So again, I'm the PI and head scientist of the Orthogonal Lab. Jesse Parent, who's here at Envision, is the lab manager, and I encourage you to contact us